आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सॉल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start with the question. The question says that define the term mobility of charge carriers in a current carrying conductor. Obtain the relation for mobility in terms of relaxation time. Let's solve the question. Now, what is mobility of charge carriers? So, the mobility of charge carriers in a current carrying conductor can be defined as a net average velocity with which the free electrons move towards the positive end of a conductor under the influence. Now all of this happens under the influence of external electric field that is being applied. Alright, so in words we can write it as the mobility of charge carriers. Now this charge carrier in a current carrying conductor can be defined as the net average velocity. Net average velocity with which the free electron move towards the positive end. Positive end of a conductor under the influence of a magnetic field. So this is also important because it happens under the influence of an external electric field. Next, how can we define mathematically? Mathematically, if we denote mu as our mobility, we can define it as our net average velocity divided by our external electric field, which is denoted by E. So Vd here is the drift velocity of the charge carriers or electrons. In E is the electric field that is being applied. Alright, so for the next part of our question, we have to obtain a relation between mobility and relaxation time. We first need to find the relation between drift velocity and relaxation time for that. So let's do that first. So here, if we assume that an electron with charge E takes time t in between collisions. So let an electron with charge E takes time t between collisions. Alright, so we will refer to this average time t, or this time t that happens between collision, as the relaxation time, because the electron is not undergoing any collision between, it's kind of relaxing between collisions. So this is known as the relaxation time. Now that we know that if the external electric field, which you denote by capital E, is acting on it, that means the electron will be experiencing a force. So the force on the electron because of the external electric field will be given by force on the electron to external electric field is given by the expression F equals negative of the charge of the electron times the electric field. Now from this we can find the acceleration of the electron, as acceleration is given by A equals minus of charge times electric field by mc. Now we know that force is mass times acceleration. Rearranging that equation for acceleration, we can get acceleration as force by mass. So we're just substituting the value of F in A equals F by m, where m of E is the mass of the electron. Now if we assume the initial velocities of each electron to be 0, that is, assume all electrons to be at rest initially, then we get the drift velocity using the formula V equals U plus AT. Now substituting the values which we initially got, now in this case we are assuming that it is at rest initially, so our small u, our u will be 0, and then we have the expression for acceleration, and t is our relaxation time in this case, and our v is drift velocity. So substituting all of these, now assuming that electron is at rest initially, so we get our new expression as Vd, which is a drift velocity, equals 0 plus the expression for acceleration, which is negative of electron charge times the electric field by mass of the electron times the relaxation time, which is denoted by T. Or simplifying the equation, that is just ignoring the zero, we get Vd equals negative of small e times capital E by times T. Now let us substitute this equation in the equation of mobility. Remember how mu is equal to drift velocity by the electric field applied. So if we substitute this into a mobility equation, we get, substituting equation for mobility, we get mu equals, now solving this, we get minus E, which is the charge of the electron, by mass of the electron times the relaxation time. With this we can conclude our answer. Therefore, mobility terms of relaxation time is given by the expression mu equals minus E by me times T, where small e is our electron charge, m of E is the mass of the electron, and T is the relaxation time or the time between each collision. Thank you.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।